Yes. Good morning, students. आज yes, the voice must be audible. So आज हम बैंक रोड के ऊपर कार रन करेंगे एंड देन वी विल सी दैट व्हाट विल बी द डिफरेंस इन द वेलोसिटी वी कैन गेट. अभी तक फिलहाल हमारे पास जो वेलोसिटी है, द फार्मूला दैट वी हैव डिराइव्ड विदाउट बैंकिंग ऑफ द रोड इज म्यू आर जी, जहां पर हमारी वेलोसिटी किस किस फैक्टर पे डिपेंड कर रही है. आर के ऊपर रेडियस ऑफ द कर्व, जी के ऊपर एक्सेलरेशन ड्यू टू ग्रेविटी, एंड द थर्ड फैक्टर इज म्यू, कोफिशिएंट ऑफ फ्रिक्शन. नाउ व्हेन वी टॉक ऑफ द कार, only the surface in contact with the road is the tire, and we already know that the friction that a circular surface possess is already very less. So, and the area of contact is less as well. That offers the friction. So the value of mu means, if we want to increase, is again a constraint for us. Constraint means a hurdle for us. And if we increase the friction, there is another factor, that wear and tear of the tire will be greater. Means you will have a lot of problem in changing the tire on regular basis. So that's also expensive. So we had to come up with a solution where coefficient of friction may not increase and we can attain a greater velocity. Okay, so in that content, what we did, we banked the road, and how it helped us, that will be at the end of this, the expression that will derive with V. One thing you may understand, that the coefficient of friction mu has to be decreased or to become negligible in order to have better life of tires. Okay, so mu has to decrease, but if we'll decrease mu, the V, as per the formula that we have derived without banking of road, the V will decrease as well. So we cannot move on that circular track with greater velocity. Now we are banking the road. This is the center point of this road, the circular track. The farthest end, the edge is raised. This is the normal track, the one which I am drawing with the blue line. This is the normal track without banking. The edge has been raised by angle theta. I'll draw a bigger diagram for you, because there will be so many components and you may get confused. Let me draw a big diagram for you. This may be the road without banking, and let us raise the farther edge from the center, जो दूर वाला edge है, और the outer edge है. कई बुक्स के अंदर लैंग्वेज यूज की हुई है farthest edge की, और कई जगह यूज किया हुआ है outer edge की. तो हमने जो बाहर वाला edge है उसको रेज कर दिया. we are having our car running on this track. Okay, so this time the weight mg acting in the downward direction, the normal reaction force normal to the surface acting in this direction, the frictional force which is acting through the tires on the road in this direction, the frictional force. Okay, I'm imitating the frictional force from the point where mg and normal reaction force are being directed. So let's say this is small f, so we'll mention small f over here, and the angle with which the road is banked, means the edge is raised, is theta. Now this component will have angle theta, this angle will be theta, as well as this angle, it is also theta. Okay, and as far as this f is concerned, this will also have theta angle, this angle will also be theta. Now we'll resolve the components. When this car is running over this track, the frictional force is going to counterbalance along with the normal reaction force. In our previous topic, the normal reaction force was not having any component along the frictional force, तो केवल हमारी गाड़ी को जो सर्कुलर ट्रैक पे रन करने के लिए फोर्स बैलेंस कर रहा था along with the centripetal force was only frictional force. अब की बार आप देखेंगे कि फ्रिक्शनल फोर्स के साथ में हमारे पास नॉर्मल रिएक्शन फोर्स का भी कंपोनेंट आएगा, जो हमें हेल्प करेगा सेंट्रीपिटल फोर्स सेंट्रीफ्यूगल फोर्स बैलेंस करने के लिए. देखते हैं कंपोनेंट, पहले कंपोनेंट रिजोल्व करते हैं हमारी, ठीक है, देन विल सी टू इट. दिस नॉर्मल रिएक्शन फोर्स एन, पहले इसको लेते हैं हम, ठीक है. थीटा के साथ वाला कंपोनेंट हो जाएगा आपका एन कोस थीटा. इसको मैं ब्लैक से लिख देता हूं, एन कोस थीटा. और दूसरा कंपोनेंट इसका हो जाएगा हमारा एन साइन थीटा, दिस कंपोनेंट. ओके, अब है हमारा एफ फ्रिक्शनल फोर्स. इसके भी कंपोनेंट रिजोल्व करते हैं. तो इसके कंपोनेंट क्या क्या होंगे देखते हैं. हमारे पास आया थीटा के साथ वाला कंपोनेंट, जो कि हमारा है दिस कंपोनेंट एफ कोस थीटा, और दूसरा कंपोनेंट हमारा आया एफ साइन थीटा. The car is to move either ways, like either it can move horizontal or vertical. Horizontal is this one and vertical is this one. So for horizontal we are having centripetal centrifugal force, and for vertical we are having weight force and the normal reaction force acting along each other. The car is not moving upward or downward, so the forces will be balanced. and neither it is moving away from the track or inward the track, so they will also be balanced. Let me share with you the centrifugal force. Centripetal तो हमने देख लिया, the result of F cos theta and N sin theta. What will be centrifugal force? mv square by r. So we'll balance the equations. The first one will be F cos theta plus N sin theta is equal to mv square by r, and the second equation will be N cos theta equal to F sin theta plus mg. See, F sin theta and mg are acting in the downward direction, so their sum will be equal to the N cos theta, which is acting in the upward direction, and mv square by r acting in this direction will be equal to N sin theta and F cos theta acting in the away going direction, so their sum will be equal to mv square by r. So these will be the two expressions that will get. हमारा मोटिव क्या है? वेलोसिटी निकालना. तो सेकेंड इक्वेशन को थोड़ा सा हम चेंज करते हैं. n cos theta minus f sin theta equal to mg. Let this be second equation. Now dividing equation 1 by equation 2 means mv square by r divided by mg, and f cos theta plus n sin theta divided by n cos theta minus f sin theta. M will be cancelled out by m. V square by rg equal to, now we know that f is equal to mu into n, so let's put this value over here. Mu n cos theta plus n sin theta divided by n cos theta minus mu n sin theta. V square by rg इक्वल टू n, हम यहाँ से कॉमन ले लेते हैं, ऊपर से भी नीचे से भी, तो कैंसल आउट हो जाएगा. तो इसको n को निकाल देते हैं हम. हमारे पास क्या एक्सप्रेशन रहेगी? म्यू कोस थीटा प्लस साइन थीटा डिवाइड बाय कोस थीटा माइनस म्यू साइन थीटा. कोस थीटा भी कॉमन ले लेते हैं दोनों तरफ से, तो हमारे पास क्या एक्सप्रेशन बचता है? म्यू कोस थीटा कॉमन ले लिया, तो पहली वाली टर्म में से तो कोस थीटा चला गया, प्लस कोस थीटा दूसरी वाली टर्म में से लिया तो क्या हो जाएगा? टेंजेंट थीटा. ठीक है जी, क्योंकि साइन थीटा डिवाइड बाय कोस थीटा कर देंगे. अगर आपको कोस निकालना है तो डिवाइड करना पड़ेगा, जब भी हमारे पास वापस क्या आएगा? साइन आएगा. अगर कोस निकाल रहे हो तो आपको कोस से डिवाइड करना पड़ेगा साइन को. उसके बाद आता है नीचे वाली टर्म में से कोस लेते हैं, क्या बचेगा? 1 माइनस म्यू टेंजेंट थीटा. Cos theta will be cancelled out by cos theta, and v square will be equal to rg into mu plus tangent theta by 1 minus mu tangent theta, and v is equal to root rg mu plus tangent theta divided by 1 minus mu tangent theta. Now, for mu to be negligible, Why we want it to be negligible? So that very less amount of wear tear should be there with the tires, and also we should attain greater velocity. तो म्यू को हम क्या कर देते हैं, नेग्लेक्ट कर देते हैं. तो नेग्लेक्ट करेंगे तो हमारे पास क्या एक्सप्रेशन बनेगी, v इज इक्वल टू रूट आर जी टेंजेंट थीटा. Now this v velocity, it will purely depend upon theta angle. More the edge we are going to raise, this theta angle we are going to make, more can be the velocity that we can attain. Okay, so this is the expression which is independent of mu. Means now you can have tires, very less amount of wear and tear with the tires, along with the velocity, more velocity you can attain. And by wear and tear of the tire, why it is also dangerous, that if wear and tear of tire is greater amount and the tire get burst while you are traveling at a good speed, then the chances that you meet the accident are greater. So we try to reduce the friction, and mu is put to be negligible. And with this expression we purely depend upon the angle with which we bend the rod. So this is the topic, the last topic of this unit. If you have got any trouble or problem understanding it, you may ask me, I'll explain it to you. Otherwise this unit is over, then we'll start work, power and energy from the next time we'll meet. इसमें पूछ लीजिए, अगर आपको कुछ डाउट है, कुछ प्रॉब्लम है तो पूछ लीजिए. अदरवाइज विल कॉल दिस लेक्चर ऑफ.